All right, triangles, triangles, triangles. So many triangles to do today. This is a review over geometry, a little sprinkle of some new trigonometry that is about to begin. In theory, today you will not need to use a calculator at all, except for maybe a teeny tiny bit with Pythagorean theorem, but this topic you should not require a calculator whatsoever. Alright. Flashback to last year. You're sitting in your geometry class. Well, good thing we are reviewing. Okay. You have your sheet of paper. We have some little tiny baby notes today, and we will be on our way. Let's talk about some triangles. Every triangle we do today is a right triangle. That is super important. All of this trigonometry we're about to do right now, all can happen because our triangle is a right triangle. We can see we have our little tiny 90-degree angle box in our bottom right corner of our triangle. There are 4 important pieces to every single triangle that we see today. And first, we always start by looking at the angle measure. In math, in algebra, we call our angles theta. See that cool little zero with a little line through it? This is called theta. Yes. Theta is how we describe angles in algebra. In math, you might just call it angle, ABC, or angle 2, or angle X. Okay, you use a symbol and a letter. In algebra, we call them theta. Theta, theta. This is angle theta. Now, based on where your angle is, you can name the sides of our triangle. And each one has its own unique little property that helps us use our sine, our cosine, and our tangent. Not sin, not cos. Sine, cosine, tangent. Wherever theta is, the side that touches it, that is not our longest side, is called our adjacent side. So the short side touching our theta is the adjacent. We usually, for short, will call it side A. The adjacent side. It's next to our theta. Directly across from our theta, opposite of our angle, this is the side that does not make up our angle. Here's our angle, our theta. This side does not include that angle. This is our opposite side, and we usually just call it O, opposite. That is this side right here, our opposite side. Last but not least, we have our hypotenuse. The hypotenuse of a triangle is always the longest side. Sometimes it's hard to tell that it's the longest side. So another good way to know this is the hypotenuse is that it is opposite of the 90-degree angle. It is also diagonal, but it depends on the orientation of the triangle. So here's our 90-degree angle. Opposite of the 90-degree angle is our hypotenuse, our longest side. We can just call it H. Hypotenuse. 4 things. We have our theta, which is our angle. Oftentimes we are trying to find this angle or use the angle to find our sides. We have our adjacent, our opposite, and our hypotenuse. And any chance you have to draw a picture, you should do it. Make sure you are drawing your pictures of your triangle to help you. So let's remember SOHCAHTOA. SOHCAHTOA is a silly little acronym to help us remember our 3 trig functions. Each trig function is specific to two sides in our triangle. Sine of theta is the ratio or division or a fraction between the opposite side and the hypotenuse. That's where we get so. Sine opposite over hypotenuse. So, sine is always the measure of the opposite side divided by the measure of the hypotenuse. Every time. Cosine is always the ratio or fraction of our adjacent side divided by our hypotenuse. Cosine is adjacent and hypotenuse. So sine opposite hypotenuse, cosine adjacent hypotenuse. So and last but not least, we have TOA, our tangent. The tangent measures the ratio between the opposite side and the adjacent side. Opposite side divided by the adjacent side is the ratio we use for tangent of theta. That's TOA. Tangent is opposite over adjacent. SOHCAHTOA is just a way to help you remember each of our three trig functions: sine, cosine, and tangent. The last trick you will frequently use in this trigonometry section is the Pythagorean theory, which again, all of this will only work if your triangle is a right triangle. Okay? We use Pythagorean theorem to do what? What does it find? The sides. It helps us find missing sides as long as you know at least two of them. Okay? So, trig, sine, cosine, and tangent will help us find angle measures as well as side measures. Pythagorean theorem helps us find missing sides. This is everything we need to know, and in theory, this is all review. Now today, other than using Pythagorean theorem, you shouldn't have to use a calculator. Okay? Everything we do for the rest of the year, you should not have to use any calculator. Actually, the biggest thing that's different from math you've taken to trig and pre-calc is trig and pre-calc, you are not ever allowed to use calculators in college. Okay? Everything can be done with simple basic math and remembering rules, tricks, theorems. Okay? So let's go into a couple examples. For each of these examples, we are going to write all three trig functions of angle theta. So we're just going to set all of them up. The first thing we need to know in order to use sine, cosine, and tangent is we need to know all three sides of our triangle. So if we take a look at our triangle in example 1, we have our theta in the top left here. We know it's a right triangle, and they gave me two sides. Which of my two sides do I know? I know the adjacent side and the opposite side. Okay? The adjacent side is, which one? Adjacent. Which side touches theta?
Oh,
5. This is our adjacent side. Because it touches theta. See theta up there? That's our angle. It touches it. 12 is then the opposite side. Because if you were to start a line at the theta, this is opposite of the theta measure, our angle. And lastly, we have our hypotenuse, our longest side. It is opposite of the 90-degree angle. We don't know it. We do not know our hypotenuse, and before we can set up our three trig functions, we have to know the hypotenuse, not the hippopotamus. Hypotenuse. So what can we use to find a missing side of a right triangle? The Pythagorean theorem. There's only one thing you have to remember in the Pythagorean theorem. It has an A, a B, and a C. What's the special of the three? C is which side? C is the hypotenuse. The A and the B can be flippity-flop, mismatched, does not matter. But your hypotenuse has to be C. So let's set up the Pythagorean theorem. A squared plus B squared equals C squared. It does not matter where I put the 5 and 12. They can be either A or B. It doesn't matter if you flip-flop them. The only one that matters is our hypotenuse. So let's fill this out. I'm going to do 5 squared plus 12 squared equals C squared. Substituting in my values. 5 squared is what? 5 times 5. Plus 144 equals C squared. And what is 25 plus 144? 169. Now, is this the measure of our side? Is our hypotenuse 169? This is what C squared is. How do I get rid of a squared? Do you remember back in the day? How do we undo a second power with a square root? Square root both sides. And what is the square root of 169? 17. Okay? So our hypotenuse is 17. Let's write it over here. C equals 17. This is the measure of the hypotenuse. 17. And now it is time to set up all three of our trig functions. I need to set up sine, I need to set up cosine, and I need to set up tangent. Okay, we're going to write our trig ratios. So let us start with sine. Sine theta equals, sine is which two sides have to do with sine? SOHCAHTOA. So, S-O-H. Opposite over hypotenuse. What is our opposite side? 12. Over, what's our hypotenuse? 17. Okay, we're just setting them up. Let's do cosine. Cosine of theta equals SOHCA, adjacent hypotenuse. 5 over 17. Is it all coming back? And last but not least, we have tangent of theta. 12 over 5. Opposite over adjacent. Now, could we pick up our computer and or our calculator and find theta? For sure. We're not doing that. We're just setting up the ratios. Okay? So we're going to do this 2 more times, or 3 more times. Okay? But before we go do that, we're going to come back to example 2. Let's go on down to example 3. Skip past 2, on to example 3. because we need to practice doing some drawing. In a right triangle, theta is an acute angle. And sine of theta is 4/7. Again, let's find the three trig functions. What should I start by drawing? I should draw a right angle inside of our triangle. Now, does this have to be a beautiful work of art? No. Here's my triangle. Here's my 90-degree angle. And I know that one of my angles is going to be angle theta. And we can pick which angle do you want to be theta in your picture. It can be either one, just not the 90-degree. Sure, let's do the bottom. Here, I'm going to make this my theta. I do. We also know what else? What other piece of information is told to us? We got our 90-degree triangle. We got our theta. It also tells us that sine of theta is what? 4/7. If sine of theta is 4/7, that means what sides do we know right now? We know two of our sides. We know the opposite is 4, and we know the hypotenuse is 7. So we go to our picture and we add them in. Where is my opposite side? If this is theta, which side is opposite? The one standing up. We know this is 4. And we know that 7 is my hypotenuse, my longest side of the triangle, opposite of the 90-degree angle. Here it is. 4 and 7. Sadly, we can't set up any more of our trig functions. And our goal is to set all three up. We already have sine. We still need to do cosine and tangent. But can I do cosine and tangent without my last side? No, that's my opposite side. And how are we going to find our opposite side? Pythagorean theorem. A squared plus b squared equals c squared. A little bit different from last time because we know one of our short sides and we know the hypotenuse. We're missing either A or B. So when we plug these in, we want to put them in the correct spot. Does it matter if I put 4 in for A or B? Doesn't matter. But it does matter that I put 7 in for 7 is the hypotenuse, which means it has to go in for C. Okay, so I'm going to just leave my A squared. A squared plus 4 squared equals 7 squared. So we have A squared plus 16 equals 49. In order to get A squared, what am I going to do? How do I get A squared all by itself? Subtract my 16. If I subtract 16 over, I'll be left with A squared equals 33. This is what A squared equals. I want to know what A equals. So last but not least, I take the square root of both sides. A equals, the square root of 33. Let's plug and chug. Any guesses? 5.7. Okay, so we know our opposite side, our adjacent side, and our hypotenuse, so we can set up our other two trig functions. Right? Cosine and tan. Okay, what is cosine's ratio going to be? 5.7. Yep, over our hypotenuse. Adjacent over hypotenuse. So ca, C-A-H. Adjacent hypotenuse. And tangent's gonna be TOA. Opposite over adjacent. Bingo. And guess what? All three trig are set up. Good to go. We done did it. Alrighty.